Hopefully this is working. Can't tell, I have to have my computer and my iPad hooked up. So I'll just do the homework, and then in a separate recording, I'll check to see that it worked. And on a separate recording, I'll start the classwork that we did today. So last night's homework from chapter notes, what's a coefficient? Coefficient is the number in front of a compound or an atom, which in this case in number 2 is that one, because this little guy is the subscript. This 2 is the coefficient. So I'm going to use that word a lot. All right, if you watch the video, he goes through it. He has little manipulatives. It might help to look at that. I can't possibly draw that every time we do it. He also shows the number of atoms specifically. I don't do that either. I can show you a few times here, and then you can decide whether you can do it without it. Most people can once they get a little bit of practice in. So what we're doing is we're trying to view this arrow as an equal sign. If the number of atoms on the left equals the number of atoms on the right of specific elements. So in this case, we see that 2 under the hydrogen, so there's 2 hydrogen here. I can't add a 2 here as a subscript in the middle of HCl because hydrogen's a +1, chloride's a -1, so there wouldn't be a 2 there. I can add a 2 here though. That's the coefficient. That means there are 2 HCl's separate. If I had an H2Cl, that would mean I'd have a Cl that had 2 H's attached to it. And that's not what I have. I have 2 separate, not touching HCl's. Okay, erase that, give me some room. And when I add that 2 in the front, it also gives me 2 chlorides. So 2 H's and 2 Cl's. I already have 2 Cl's. So we're done this problem. The reaction is balanced. You can leave the spaces in front of H2 and Cl2 blank, or you can put a 1 there if you want to fill in the spaces, but for the most part, we usually leave them blank. Oops, I didn't erase that. Second problem, we have 2 H's on the left and 2 oxygens. We have 2 hydrogen on the right and only 1 oxygen. It's an invisible subscript. So we need more oxygen. So the way to fix that would be adding a subscript or a coefficient in the front. If I add a coefficient in the front, I now have 4, 2 times 2, hydrogen, which I wasn't fooling with because they were equal. I just screwed them up now. But I had to because I had to add more oxygen. So 2 H2O's means there are 2 separate H2O's. So that's a total of 4 hydrogen and 2 oxygen. See how that works? But I needed 2 oxygen because I had 2 on the left. Now I have 4 hydrogen, so I needed 2 there in front of hydrogen. We're multiplying 2 times 2, not 2 plus 2. They're both 4, but we're multiplying there. So this reaction is done because I have, always double check, 4 hydrogen on the left, 2 times 2, 4 hydrogen on the right, 2 oxygen on the left, and because of this 2 here, I have 2 oxygen on the right. I can't rewrite this H2O2 because that's hydrogen peroxide. It's not water. You can't change the identity of the substance, but you can add more H2O molecules. Now what Tyler was doing in the video was he was making a list, which I don't really have room for here. If you want to make a copy of the document and add spaces, that would be a good idea. If you want to write out how many atoms you have, he was making a list of the reactants and the products. So how many N's, how many H's, and that's the only 2 elements. Over here, put N and H in the same order. So you're going to compare them on the left and the right. So reactants are on the left, I have 2 nitrogen. So I'm going to put a 2 here to keep track. I also have 2 hydrogen. So I put a 2 there. On the right, I have just 1 nitrogen and 3 hydrogen. So nothing is balanced. The hydrogen on the left does not equal the hydrogen on the right, and the nitrogen and the hydrogen don't match either. So we have to add coefficients to the front to give more of one thing or the other. So I see right away I have 2 nitrogen and 1 nitrogen. So I'm going to add more nitrogen by putting a 2 there. Now I've changed the nitrogen. So now I have 2 nitrogen and 6 hydrogen on the right side. So while my nitrogen has been fixed, I screwed up. Well, I was already screwed up. I have 2 hydrogen and 6 hydrogen. So I need more hydrogen on the left. So how do I get 6 hydrogen? Well, I'm going to put something in front of it. So what times 2 equals 6? 3. 3 times 2 equals 6. So that will fit. That's it. Finishes it up. Right, so the extras. So we have 2 nitrogen on the left, 2 nitrogen on the right. 6. 2 times 3 is 6 hydrogen on the left. 3 times 2, 6 hydrogen on the right. So because I changed, what did I change? I changed that to 6. See, I don't keep track of it, but you can if you need to write it all out and see it. That's one way to do it. Make a list and keep changing it just by counting and try to make them equal on both sides. All right, number 5. All right, so we have 1 R. We can make a list if we want. F. I have 1 R on the left and 2 Fs on the left. On the right, I have 1 R and 6 Fs. So my R's are fine. My F's, I'm missing some on the left. I need more on the left. So in front of F, because I already have 2, what number would I put there so that I'd have a total of 6? And the answer is 3. So 3 times 2 is 6. And I have 6 on that side. So that problem is done because there's still 1 R there and there's still 1 R there. Okay. We don't show those subscripts of 1 now, remember that? So on number 6, I have 1 D. I have 2 Ds. I'm not going to write all this out because that's not that difficult to see that I have 1 on one side and 2 on the other side. I need more on the left. So I'm going to put a 2 there. Okay. And then I look at the H's. I have 2 H's on the left. I have 2 H's on the right. Balanced. I have 1 L on the left and 1 L on the right. So everything's fine. Everything's fine. It's done already. Number 7. These are highlighted in yellow so that you can see that every substance has an oxygen. So all 4 substances. How many substances in number 7 have an oxygen? All 4. So the left has to equal the right. You don't need like a 3 for each of the ones on the left. You just need the total to be the same on the left as the right. So let's start with the R. 1 R there, 2 R's here. I need more R. I would leave oxygen to the end because if you wind up changing the R's or the M's or the H's, it's going to affect the O's. So I put a 2 there so that I have 2 R's. Now the M's, 1 M there, 1 M there. So he's good. The H's, well, I put a 2 here in front of this H, ROH. Every capital letter is a new element. So I have 2 H's. I have 2 R's, 2 O's, 2 H's in this first part compound. On the right side, I have two H's already also. So hydrogen's fine. So it's just the oxygen we want to look at and count all them up. So different color. Right here, I have two oxygen because I have an ROH and then second ROH. So I have two oxygen there. In the second, or adding these together, compound, I have two oxygen. That gives me a total of 4 oxygen on the left. On the right, I have 3 oxygen and 1 oxygen, which gives me a total of 4. So that's balanced. So see how I added up the left to equal the right. Next one. 1Fa, 1Fa. 2x, 1x. Put a 2 there. Now I have 2 FAX. So we have a capital letter and a lowercase letter. So that's one element. Each capital letter is a new element. So 2FA, and now I need 2FA on the left. So I put a 2 there. And that's balanced. 2FA on the left, 2 on the right, 2 X's on the left, 2 X's on the right. Double check and then make sure that ratio is simplified. So if you wind up with something like a 2, 4, 2, they can all be reduced to a 1 to 2 to 1 because you can all divide them all by 2. But we don't need that right there. Sometimes it happens when you're doing a problem, to double check. All right, number 9, 1Z, 1Z, good. 1 O, 2 O's. Need more O's on the left. So I put a 2 there. Now I have 2 Z's though. So I put a 2 there. 1M, 1M, done. Okay, number 10, SI is one element. I have 1 SI, 1 SI. I have 2 O's, 1 O. So I need more O's on the right. But now that gives me 2 M's also. And I've got an M here. So frequently that's missed when there's more than one element. See, I've got an M there and an M there, but only one M on this side. So I'll need to add these M's up. So I have 1 M here plus 2 M's. That gives me a total of 3 M's. So I need a 3 here. And that's it. Let me do that one again real quick. I guess you can rewind. You don't need me to do it again. SI, SI, good. O2, O, just 1, add a 2. M's, 1, 2, 3, equals 3. So all you need is a 3 and that 2. And that's it. All right, let me see if I can figure out how to stop recording. Come to homeroom for help. If I can figure out how to do another video, I'll do it with the classwork. Stop broadcasting. And then how do I get out? End.